This lesson will explain how to update the weight and balance records of an aircraft following alterations. Additional information on this topic can be found in the FAA General Handbook, Chapter 4, and in the FAA Weight and Balance Handbook. Anytime permanently installed equipment is either added or removed from an aircraft, or an alteration is performed that affects the weight and balance of the aircraft, a new weight and balance report must be completed. This can be accomplished by either reweighing the aircraft or by mathematically calculating the new empty weight and empty weight center of gravity. Let's look at an example of how to calculate a new empty weight and empty weight center of gravity of an aircraft after the removal of two seats and the addition of a cargo door and a backup battery. Let's start with an aircraft with an empty weight of 1,792 pounds with an empty weight center of gravity of 97.6 inches. We will consider removing two seats that weigh 17 pounds each and are located at 114.9 inches after the datum, installing a cargo door that weighs 22 pounds located at 123.4 inches, and installing a backup battery that weighs 14 pounds located at 125.8 inches. We will find the new empty weight and new empty weight center of gravity for this aircraft by again using our item, weight, arm, and moment chart. We will begin to fill out the chart by listing our items, the aircraft itself, the two seats that are being removed, and the door and the battery that are being installed. We will then input the corresponding weight and arm for each item, remembering that if an item is being removed from an aircraft, its weight is listed as a negative number. Once we have each weight and arm for each item, we then calculate an individual moment for each item, remembering again that if I have a negative weight multiplied by a positive arm, I'm going to end up with a negative moment. Once I have calculated all the individual moments, I will sum them together to get a total moment. Again, remembering doing this addition that I have a negative moment up here to add into it. And then over here, I will sum all my weights together to get a new empty weight for the aircraft. Once I have obtained my total moment and my total weight, divide my total moment by my total weight to get my new empty weight center of gravity of 97.8 inches after the datum. Recognize then that after these alterations and changes to the aircraft, our empty weight center of gravity has moved 0.2 inches aft of its original location. Let's look at another example of how to calculate a new empty weight and empty weight center of gravity of an aircraft after equipment changes and alterations have been made to it. Let's start with an aircraft with an empty weight of 1,468 pounds and an empty weight center of gravity of 63.5 inches. Let's remove a two-blade prop that weighs 34.7 pounds and is located 21.6 inches forward of the datum, and add a three-blade prop that weighs 46.2 pounds and is located at 21.6 inches forward of the datum. Let's remove a rear seat that weighs 46.9 pounds and is located at 98.1 inches, and install a floor panel that weighs 32.7 pounds and is also located at 98.1 inches. Again, we will utilize our item, weight, arm, and moment chart in making these calculations, and we will start again by listing the items involved. First, our aircraft, the two-blade prop that is being removed, the three-blade prop that is being installed, the seat that is being removed, and the floor panel that is being installed. Then we will input the weight and arm that corresponds to each item. Remember again, if I'm removing an item, such as our two-blade prop or our seat, that the weight will be a negative number. And also remember, if my arm is forward of the datum, that is going to be a negative distance. Once I have my weight and arm for each item listed, then I will calculate again an individual moment for each item. And remember, if I have a positive weight and a negative arm, I'm going to end up with a negative moment. Or if I have a negative weight and a positive arm, I'm going to end up with a negative moment. Once I have all my individual moments listed, add them together to come up with my new total moment. Add all of my individual weights together to come up with my new empty weight. Again, I will divide my total moment by my total weight to get my center of gravity. In this example, I now have a center of gravity that is 62.5 inches after the datum, or 1 inch forward of my original center of gravity of 63.5 inches.